here in terms of how to find this notation, how to find this item to find the answer here. So if you don't have a question, let's take a look at this item here. So again, let's say that this is our problem. This is our question here, which is, like I mentioned to you guys, this is the only 3 questions that they will probably ask you. You just have to ask yourself, greater than, what does it mean? Greater than meaning bigger than something meaning it's on the right hand side, right? Think in terms of the number line, anything on the right hand side is bigger than the thing on the left hand side. Okay, so greater than is the thing on the right, less than is the thing on the left. Between, there's no sugar coat, between is just between the 2 values. Okay, so when you see this problem on your homework, this is what you need to ask yourself is, this is what I want you to do. First, you want to sketch your normal distribution curve, right? It doesn't have to be perfect. It's just give you an idea of what will be your lower endpoint and what will be your upper endpoint. Okay, so looking at this thing here, they ask you what is a proportion of the population is greater than 100. So greater than 100, everybody see that anything to the right is bigger than 100, which is, in this case, this is what I'm looking for. I'm looking for the area to the right of 100. So if we're looking for the area to the right of 100, then all I need to do is, now I need to use my normal CDF. What will be my lower limit? My lower limit, as you can see, if we walk from left to right, the first time we hit this thing is at 100. And we keep on going, which is, we tell the calculator, calculate this region, which is 100 all the way up to 1,000,000, right? So again, you just type in normal CDF. Your upper limit will be 100. Sorry, your lower limit will be 100. Your upper limit will be, again, 1,000,000. In this case, I type 10 million. Again, this number does not matter. Like I say, more than 1,000, it should be work. I just put 10 million to make sure. You just need some big number, okay? And again, because beyond this is like the probability of this is very small. It doesn't affect any outcome. It's very close to 0. So looking at this thing here, everybody see where my 61 come from? My 61 is the mean. And again, my 16 is standard deviation, right? Which is, again, my data is normal. That's why we're doing this. Again, without this thing here, we stop. Right? So mostly they will tell you your data is normal. Okay. So again, once you type this thing in, which is, again, 0.0074 is your answer. And again, they can ask you, is this unusual? And hopefully you say, yes, this is unusual, right? It's less than 0.05, right? This is not even 1%, right? So again, looking at this thing here, the idea of this problem is, like I mentioned, hopefully you guys can sketch your normal distribution curve and ask yourself, am I looking for the area to the left of this endpoint, or am I looking for the area on the right of this endpoint? Okay, so again, above, greater than, or to the right is to the right. Less than, below, or to the left is the left endpoint, which is, again, what is the probability? Don't confuse yourself. Proportional population and probability is the same. So again, what is the probability of a random choosing value is less than 80, which is, as you can see, 80 is here. Less than 80, I'm looking for the item on the left-hand side, right? And again, some student ask me, does it have to be precise? It doesn't, right? It's just a sketch. It just gives you an idea. Just give you an idea. You draw your curve, right? You don't have to be, it doesn't have to be perfectly even. Just put the curve on your paper, like some curve, and then just put the line and ask yourself, do I shade it to the left or shade it to the right, right? You can draw however shape. You can just draw a number line and put a line through it and just say, do I shade it to the left, to the right, right? So again, this thing here doesn't have to be exactly at this point. You can put one line here and you say, okay, that's my 80. That's my boundary. Do I looking for the item on the left or on the right of that boundary, right? So again, however you sketch it, that's how you sketch it. I mean, this thing here, because it's on the computer, so I use in the picture. If we were to be in class, my sketch is not this perfect. So again, you just draw, draw a line and just put like a mountain on top of that line, right? I don't know how to describe to the screen, but again, you just draw like a small mountain, and then just draw your line. Tell you, okay, this is my point. Do I find the item on the left of this point or on the right of this point, right? So because it's less than, I'm finding the item on the left, and this thing should give you that, oh, the item on the left, my lower limit will be some small number, right? Because I'm looking for the item on the left, my lower limit will be negative 1 million or 10 million. My upper limit, which is again, I will not go beyond 80. So my upper limit will be 80. And then my mean is 61 and my standard deviation is 16, which is once you have this, your calculator will do the rest, which is again, 0.8825. And again, if you're looking for C, how do we sketch this thing here? Because there's no sugar coating. If they ask you in between, which is again, in between, that's it, right? We're looking for the area in between, which is, this is where I shaded. I shade the item in between. So once I shade the item in between, which is again, what are the two value? 59 is the smaller number, 72 is the upper limit, which is again, I type in normal CDF, 59, 72, 61. Which is the mean, 16 is the standard deviation, and then you type in your calculator this way. And again, you will get 30.3039. So again, just the sketching part is not necessary if you understand where your endpoint comes from. If you know that if you're looking for the item on the right and you have some small number and your upper limit is some humongous number, that's fine. You don't have to sketch them. The reason why I ask you to sketch them is to show you that if you shade it to the right, your upper limit will be some humongous number. If you shade it to the left, your lower limit will be some negative humongous number. And if you shade it in between, the two number is your endpoint. That's the only goal that I give you this three pictures so that you can identify which endpoint we're using, because to tell your calculator to calculate, you have to tell them, I want you to calculate from this group of number. I want you to calculate from this group of number. I have the mean, I have the standard deviation. Go ahead and calculate this group of number for me, right? So again, that's the only reason why I ask you to shade the region. You don't really have to necessarily shade it if you know your endpoint. So question with this three problem, in terms of how to type in your calculator, how to shade the item, or how to take the question and take the figure and correlate back to the question. Any question here? If you can do this, ladies and gentlemen, this is all of chapter 6. The only thing different is they changing your standard deviation a little bit here and there. But again, all you're doing is you find the area underneath the curve. Okay. Well, not quite. Let's take a look at, if you don't have question with this thing here, let's take a look at the second thing that we have in chapter 6.1. What happened if they reverse the script? Right? What happened if they reverse the script? Instead of actually find the area underneath the curve, they give you the area and they ask you to give them the z-score, right? What happened if they reverse the direction, right? So again, this is what math is, right? Math, if we teach you how to add, we have to teach you how to subtract, right? The opposite, right? So now if we ask you how to find the area underneath the curve, now we have to know how can we reverse that operation. How can we, if we give you the area, can you find me the data or the z-score or whatever the item here, right? So this is what we ask you to do, or this is the other item that we have, which is, again, trust me, you guys have this easy, because when I took this class, I don't have, my teacher doesn't allow a calculator. We have to do it by chart. And this is the one that kill me the most. Is very confusing in terms of using the chart. But for you guys, you have it May in terms of this is what you have is we're using the calculator, and the feature that we're using is the inverse norm. So just like the name, inverse norm, which is the inverse of the normal distribution, right? So instead of the normal distribution, which is you find the z-score, we have the inverse norm, which is now you tell the calculator, this is the information they give me, find me, reverse the operation for me, and give me the answer, right? So there are two things on, well, there are one thing different is we don't have a lower limit or upper limit anymore, right? Because they give us an area. So to using this feature, inverse norm, what you need is or the only thing the calculator can do is they can only calculate the area to the left of the value. Make sure that the calculator can only calculate the area to the left of the value. So you give them the area to the left. And the two things I told you that we need is we need the mean and we need the standard deviation. Okay. So again, given this thing here, for instance, let's say that this is a standard normal curve, right? A standard normal curve. The area to the left of this point, I don't know what this z-score is. The area of this is 0.26. Now I want you to go in and tell me what is the z-score, right? So we know that if it's less than 50%, the z-score have to be some negative. I did not have any. Give me 1 second. Let's see. Let's go back to here. So this is what they ask you, right? They ask you, given this thing here, give me, let's say that if I make up the question, I make up that this is my standard normal curve, right? Remember, standard normal curve, the mean is 0 and the standard deviation is 1. So I have a standard normal curve, and now I have 26% to the left of this thing here. You go back and tell me what is the z-score, right? So again, how do we do this? We have to hit second var, right? And again, instead of using normal, we tell the calculator do the inverse norm. The inverse INV inverse norm, which is you tell them inverse norm. And again, looking at this thing here, what is the area to the left? The area to the left they give us is 0.26. Reminder, your area will always be a decimal, right? Don't give them 26%. If it's 26%, it's 0.26. What is my mean? My mean is 0 and my standard deviation is 1. So if you type that in, they will tell you that the z-score is negative 0.64335. So roughly negative 0.643, right? So that's your z-score, which is again, if you do it the other way, remember your inverse, your normal, if you do it, your normal, if you do negative 1 million, right? If you do negative 1 million, comma, negative 0.6433, comma, 0, comma, 1, they should give you the answer to be 0.26, right? Which is again, everybody see that earlier, right? The prior slide, the previous slide, we're looking for the z-score. And if we're looking for z-score, we put in a normal CDF. But now they reverse the script, they reverse the direction, and they ask you, find the z-score. I only know the percentage. I don't know the corresponding z-score. Can you find the z-score for me? Which is again, to find the z-score, you put in inverse norm. And the feature for inverse norm, which is the feature for inverse norm, is you need to have the area to the left of the z-score, or the area to the left of that item, the mu and the sigma, which is the mean and the standard deviation. Okay, so let's take a look at this example here. Let's take a look at this example, and then we can call it off the day. We can call it so let's take a look at this thing here, which is like I mentioned to you guys. Sketch the graph, so at least you know what we are looking for. Okay, just sketch it. It doesn't have to be nice. It just need to give you an idea. So again, this is what we have is if they give you the area to the left, life is good, you just plug it in, the area, the mean, the standard deviation, we go on. If they give you the area to the right, we cannot put the area to the right in the area region. We have to take 1 minus the area to give me the area to the left. Okay, so let's take a look at this thing here. So they ask you find the z-score, which is the z-score is a standard normal. Even though they don't say right here you have a standard normal curve, when they say find the z-score, which is your standard normal curve, for which the area to the left is 0.13. So to do this thing here, which is again, to do this item, hopefully you guys see that to do this item here, all we need to do is, again, do you agree that they give us the area to the left? Right, which is the, yeah. So I sketched this, right? Again, this is what I have is, again, my standard normal. This is my standard normal. I sketch this and I say, okay, they give me the area to the left, which is the area to the left is 0.13. So that's all I needed, right? All I need is the area to the left, which is area to the left is 0.13. Now all I need to do is plug into this thing here, which is, again, second var inverse norm, which is INV norm. And again, I put 0.13, comma, 0, comma, 1. Close my parenthesis. And again, this is what I should get, which is negative 1.1264. So again, looking at this thing here, and if you have the TI-84, they tell you the percentage, they tell you the mean, they tell you the standard deviation, which is easier than 83. 83, you have to manually type it in. So again, you type in inverse norm 0.13, 0, comma 1, you should get negative 1.26, right? It depends on your connect math. They tell you how many decimal they want it to be, right? It's either negative 1.1264 or negative 1.126. And again, we know that it's negative, right? Because 50%, that's 0. This thing is less than 50%, so it's got to be some negative number, okay? And now let's take a look at B, and then we can call up the call for the day, which is, again, B, they ask you this question here, which is, again, find the z-score for which the area to the right is 0.05. So which is, again, looking at this thing here, if I sketch it out, do you agree that over on the right-hand side is 0.05? But again, my item, I didn't delete this. My item is, remember, the feature the calculator can calculate is only the item to the left, right? So this thing is on the right. I cannot just put the 0.05 and tell my calculator to calculate it, because that will give me a negative number. To do this thing here, I have to take 1 minus this item, 1 minus 0.05 to give me 0.95, which is now, if I know over here is 0.05, do you agree the leftover is 95 here, which is 0.95, which is the area to the left of this thing here is 0.95, comma, 0, comma, 1, which is, again, the z-score will be 1.645, okay? So given this thing here, this is what we have, okay? If you say, Mr. Tran, can I do 0.05 and then change in the value? If you remember, yes. Because they are symmetric, if you put 0.5, you will get negative 1.645. Again, because you tell them to calculate this number, they are symmetric, which is, again, if you know that it's on the right-hand side is positive, you can do that. But again, to do this thing correctly, this is what we do, is they give us the item on the right. So you tell your calculator, okay, this is what I have on the left, because the calculator only calculates the area to the left. So we need to compute and find the area to the left and tell the calculator to do it, okay? But again, this is what we need to do, which is, this is the only thing that left in terms of 6.1, which is how do we do the inverse operation of the normal distribution, which is how do we find the z-score, or how do we find the data from the information, okay?